Alright, so hopefully you made the three triangles and measured all the three sides of the triangle. Now in my case, I made these measurements and I'm going to fill them out in centimeters. 4.6, 1.3 and 4.2. Then I have 5.8 and 1.7 and 5.7. Then I have 7 and 2 and 6.5. Okay, you will have different numbers. Now again, we are already established there's no clear relationship, right? These are just a bunch of numbers right here. So we're going to go ahead with our intuition of looking at ratios. So fill this out with the ratios that you have. I'm going to do that for mine. Let's see, that's 1.3 over 4.6, approximately 0.28. Then I got 4.2. So you can go ahead and do your calculations while I do these right now. Divide by 4.6, roughly 0.91. EB, that's 1.3 divided by 4.2, 0.31. Next triangle, FC is 1.7 divided by 5.8, 0.29. AC is 5.5 divided by 5.8, roughly 0.95. FC is 1.7 divided by 5.5, 0.31. And lastly, GD over AG, 2 over 7, roughly 0.28. AD is 6 over 7. It's going to be roughly 0.92, and 2 over 6.5, which is 0.31. Now the interesting part is, even though you may have different numbers, the ratios that you have, in your case, in all three triangles, should be somewhat similar. Now, what do I mean? Look at this: 0.28, 0.29, 0.28, close, 0.99, and 0.3. Yeah. So if you did this correct, you would also have or notice this particular pattern or observation in what you did. So this is good because our intuition of connecting angles with ratios of side has some future. Okay. Now the reason these ratios line up is because the angle A is shared between all the triangles. Yeah. So at this point, now because our intuition or our guess that angles are related to ratios of side is somewhat confirmed, we're going to go ahead and embark upon this study, which is called the study of trigonometric ratios or trigonometry. Now given a right triangle ABC, there are 6 possible ratios that can be formed using 3 sides. Now think about it. If I give you 3 numbers, 2, 3, 5, how many ratios can you form? You can form 2 over 3, 3 over 2, 3 over 5, 5 over 3, or 2 over 5, 5 over 2. There's only 6 possible. Right. In this block, each of these are reciprocals, meaning they are not exactly very much unique. And then these are assigned 6 different names. So these names are important and are specific, right? So this ratio is different from this ratio, so it has a different name. So AC over BC is sine. So the names are sine, cosine, tangent, cosecant, secant, cotangent. So it's simple. 6 possible ratios, we give each of them a name. And what these ratios depend on is the angle. This angle theta. So here's a mnemonic to remember them. If you are given a right triangle and the angle, then you label these sides. This side is always the hypotenuse because it's a right triangle. The side that is opposite is called the opposite, and the side that's adjacent is called the adjacent. And the mnemonic is SOHCAHTOA. So it says sine is opposite over hypotenuse, so SOH. Cosine is adjacent over hypotenuse, so CAH. And tangent is opposite over adjacent, or TOA. Let's look at an example. In the following triangle, find the 6 ratios. Okay, so that's my angle. So that is opposite, that is adjacent, and that is hypotenuse. So sine is opposite over hypotenuse, so 4 over 5. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then these ratios are just reciprocals. Cosecant is a reciprocal of sine, so it's 5/4. Secant is a reciprocal of cosine, so it's 5/3. And cotangent is a reciprocal of tangent, so it's 3/4. Okay. Now you may not have nice numbers, so in this case, if I'm going to fill this out, the only difference here is, remember, this theta now is up here, which means with respect to this angle, that is the opposite, that is the adjacent, the hypotenuse never changes. So in this case, sine theta is 1 over root 2, cosine is 1 over root 2, tangent is 1. So this is root 2, 1. Now in this case, these ratios would come out the same even if you consider this angle. Why? Because these two sides are same. It's an isosceles triangle, so these angles are also same. Okay, next video we're going to look at an interplay with Pythagoras.